Welcome to Learning Life Content. Please like, share, comment and subscribe. Your support helps us grow and motivates us to bring you more fascinating and enriching stories. Look around you. Every step you take, every building you enter, every bridge you cross, there's a silent companion beneath and around you. Beneath your feet and all around lies a material so common we barely notice it. Cement. It's the invisible backbone of civilization, holding together the world we've built. It's the magic powder that, when mixed with water, sand and stone, creates concrete, the artificial rock that shapes our world. Did you know that concrete is the most widely used man-made material on Earth? From the soaring skyscrapers that define our skylines to the humble foundations of our homes, cement is the binding force of civilization. It's in the tunnels beneath our cities, the dams that hold back rivers, and the roads that connect us all. Its story stretches back thousands of years, connecting ancient Rome to today's metropolises. The Romans were among the first to master cement, using volcanic ash to create structures that have stood for millennia. Imagine the Pantheon's dome in Rome standing for nearly 2 millennia and the Burj Khalifa in Dubai, the tallest structure ever built. Both owe their existence to cement. The secret of Roman concrete's durability? A unique blend of lime and volcanic ash that actually grows stronger over time. This remarkable substance lets us mold our environment, build shelters, bridges and structures that defy nature. With reinforced concrete, we can create shapes and spans that would have been impossible with stone alone. The journey began with the simple need for durable shelter. Early humans discovered that certain muds and clays could bind stones. The first mortars were humble, but they laid the groundwork for everything to come. Over centuries, this knowledge evolved. Burning limestone produced a powder that hardened with water, the dawn of hydraulic cement. The word cement comes from the Latin cementum, meaning quarry stone. Today we produce billions of tons of cement annually, second only to water in global consumption. In fact, every year enough concrete is poured to build a wall 27 meters high and 27 meters thick around the equator. Cement forms the backbone of our infrastructure. From roads to water pipes, from airports to tunnels, it's even used to line canals, protect coastlines and create artificial reefs for marine life. Yet its creation is energy intensive and leaves a significant environmental mark. Cement production accounts for about 8% of global carbon dioxide emissions, more than all the world's trucks combined. As we continue to build, we must innovate, making cement more sustainable for the future. Researchers are developing new formulas, using recycled materials, capturing carbon, and even creating self-healing concrete that repairs its own cracks. The foundation of our world is strong, but its future depends on our ingenuity. The next chapter of cement's story will be written by those who dare to rethink and reinvent. Cement's story is one of progress and responsibility. It's a tale of human ambition, creativity, and the constant push to build higher, stronger, and smarter. Every structure we build is a testament to this silent grey giant. From the world's largest dams to delicate works of art, cement's versatility is astonishing. The challenge now, to ensure our foundation endures without costing the earth. The future of cement is not just about strength, but about harmony with our planet. The story of cement is the story of us, of our dreams, our challenges, and our enduring quest to build a better world, one layer at a time. Our journey begins 12,000 years ago in Göbekli Tepe, Turkey, where early builders used burnt limestone to create quicklime mortar. This simple plaster, made by mixing quicklime with water and aggregate, allowed for more permanent, weather-resistant structures. The discovery was likely accidental. perhaps from a fire on limestone-rich ground, but it set humanity on a path of architectural innovation. Across the Mediterranean, the Phoenicians found volcanic ash near Mount Vesuvius that, when mixed with lime and water, created a mortar that hardened underwater. This was a game-changer for maritime construction, enabling harbours and breakwaters to withstand the sea. The Romans later called this volcanic ash pozzolana, but the Phoenicians had already harnessed its power. The chemistry silica and alumina in the ash reacted with lime to form durable water-resistant compounds. These early cements allowed ancient cultures to build structures that endured. Their discoveries, born from necessity and observation, laid the groundwork for future empires. The knowledge of binding stones with artificial rock would soon be perfected by the Romans. The first binders were humble, but their impact was monumental. The age of synthetic stone had begun. The Romans revolutionized building with Opus Caementicium, Roman concrete. By mixing lime, pozzolana, water and stone, they created a fluid mixture that hardened into a monolithic mass. This material enabled aqueducts, amphitheatres and domes on an unprecedented scale. The Pantheon's unreinforced concrete dome, completed in 128 AD, remains a marvel of engineering. Roman engineers varied the concrete's composition, using lighter aggregates in upper sections to reduce weight. The secret to Roman concrete's longevity? The interaction of pozzolana, lime and seawater formed minerals that strengthened over time. Many Roman structures have survived for 2 millennia, enduring earthquakes and wars. Their concrete was not just strong, it was self-healing. The Romans didn't fully understand the chemistry, but their legacy endures in concrete that still stands today. Opus Caementicium was the engine of an empire and a gift to the future. We are still learning from their accidental genius. With Rome's fall, the secret of durable concrete faded. Medieval Europe relied on timber, earth and weak lime mortars. Grand Roman techniques were lost. Some knowledge persisted in the Byzantine Empire and through guild traditions, but true hydraulic cement was forgotten. Cathedrals and castles rose, but their mortars lacked the strength and versatility of Roman concrete. The Renaissance sparked curiosity. Scholars studied ancient texts and ruins, seeking lost secrets. They improved lime mortars, but couldn't replicate Roman durability. The key ingredient, pozzolana, was elusive. For over 1,000 years, the world waited for rediscovery. The formula for hydraulic cement remained a mystery, limiting construction possibilities. Only with the dawn of science and industry would the lost art return. The stage was set for a new era of innovation. The 18th century's Industrial Revolution demanded stronger materials. John Smeaton, rebuilding the Eddystone Lighthouse, experimented with limestone and clay, rediscovering hydraulic lime that hardened underwater. His lighthouse stood for over a century, a triumph of engineering. Joseph Aspdin, a Leeds bricklayer, took the next leap. Burning limestone and clay together, he created a fine powder that set exceptionally strong. In 1824, Aspdin patented Portland cement, named for its resemblance to Portland stone. Though primitive, his process allowed for standardized, reliable cement production. Portland cement could be made anywhere, not just where natural cements occurred. Aspdin's invention laid the foundation for the modern world. The age of engineered cement had begun. Aspdin's idea was refined by Isaac Charles Johnson, who discovered that burning limestone and clay at higher temperatures produced hard clinker. Grinding clinker yielded a much stronger, more reliable cement. This high-temperature process, called sintering, is the key to modern Portland cement. Rotary kilns, invented in the late 1800s, enabled mass production. The process quarry limestone and clay, grind to powder, heat in a rotary kiln, cool, then grind with gypsum to control setting time. The result, a highly engineered, versatile powder ready for global construction. Cement manufacturing became a precise industrial science. The process is energy intensive, but it made high-quality cement affordable and available worldwide. Nearly 2 centuries of refinement have shaped the cement we use today. This is the backbone of modern construction. By the 20th century, Portland cement and concrete had conquered the world. Reinforced concrete enabled dams, highways, bridges and skyscrapers, defining modern cities. After 2 world wars, concrete rebuilt nations and fueled global development. Today, over 4 billion tons of cement are produced annually, with China leading the way. Rapid urbanization in Asia, Africa and Latin America drives demand. Cement is essential for infrastructure, housing and economic growth. The industry employs millions and underpins the construction sector worldwide. Affordable cement shapes the pace of development and quality of life. Concrete is more than a material, it's a catalyst for social and economic change. Our cities, roads and bridges are monuments to this grey powder. Cement is the silent force behind modern civilization. Cement's success comes at a steep environmental cost. Its production is one of the most carbon-intensive industrial processes. Kilns burn fossil fuels at high temperatures, releasing vast amounts of CO2. The chemical reaction, calcination, also emits CO2 directly from limestone. Cement accounts for about 8% of global carbon emissions. Quarrying scars landscapes and pollutes air and water. Concrete's impervious surfaces worsen urban heat and flooding. The industry faces urgent pressure to find sustainable solutions, green cements, recycled materials and carbon capture. The challenge matched cement's strength and versatility without its heavy environmental footprint. Cement's story mirrors our own: innovation, progress and now responsibility. From ancient plasters to Roman concrete, from Portland cement to today's global industry, it has shaped our world. But our reliance on cement fuels climate change. We can't ignore its environmental impact. The future depends on new solutions: carbon capture, alternative binders, efficient design and recycling. Biocements and geopolymers may offer hope, mimicking nature's processes. The goal isn't to stop building, but to build smarter and more sustainably. We must balance development with stewardship of the planet. The next chapter in Cement's story is unwritten, a challenge for scientists, engineers and all of us. Human ingenuity has always risen to the occasion. The foundation of civilization must evolve. Our legacy will be the world we choose to build next. Thank you for watching Learning Life content. Please like, share, comment and subscribe. Your support helps us grow and motivates us to bring you more fascinating and enriching stories.